Hi everyone, in this video we're going to talk about web scraping with httr and rvest. Okay? Httr and rvest. So what are we talking about? Httr for HTTP requests. So httr is a function that works with HTTP requests. Okay, it also works with web APIs. Okay? And then rvest for web scraping. Now that second bullet we'll actually have to cut short because, of course, recently Twitter has made some changes if you follow Twitter, and it doesn't allow, well, really anyone to work with its API anymore. And so that function, the stuff I'll talk about there is obsolete, unfortunately, unless you pay. And even if you pay, they're now limiting that. So who knows how long Twitter will be there, but I'll have to skip over that section. My apologies. Okay. And then I'll talk about a package that my wife and I made that does some web scraping that you might find really useful or also maybe useless. Okay. But we'll see. I'll show it to you anyway. Okay. And then we'll end by doing a little activity, or I'll open it up for you on your own time to do a little bit of an activity about scraping a table from Wikipedia. So now let's get into httr. So httr is a package that manages connections made with a web server via the hypertext transfer protocol, and that of course drives the web. Okay, so you type in a website and you get something back. Like if I went to the ship homepage, it gave me a homepage. It didn't give me some like blank page, right? So Safari, Google Chrome, Firefox, any web browser does this. Okay, that's all it does. Well, it does a bunch of things, but a web browser will request some information from a web server and then bring it back to show you. Okay, so HTTP requests are sent from your computer to a web server that asks the server to perform some task. The request takes the form of verbs in all caps, like this, like get. Okay, httr provides functions to manage the requests. So, as an example, there's a simple website called httbin.org for you to request something and it'll send you something back, yeah? And so here's the example, okay? Get, and then I request that website and it gives me back this. Now this is verbose, so usually it wouldn't give me all of this, but I asked it to show me everything. Okay, and it gives you a lot of information, but really what we're interested in is the, let's see, 1, 2, 3, 4, 5, 6, 7, 8 lines down after we sent things. So you notice the arrows. Arrows are pointing to the right. That's what we sent. Arrows that are pointing to the left, that's what we got back. And the first line of what we got back is probably the most important, and that is a code 200 OK. And so that's what we're hoping for. Okay, and so we might, when we don't get something back that we want, okay, you're all familiar with the code 404, which is not found. Okay, so when you go to a website and it just blanks on you, it says 404 not found. Okay, that is the code when it doesn't, well, when it's not found. If you try to access a website that is forbidden to you, that's a code 403. There are lots of different codes. Okay, and so let's try to scrape some information from a website that I know that I can, and that's the email from the math faculty page at Shippensburg. Okay, so here's a picture. It's a bit outdated because we know Dr. Barnaby is no longer Dr. Barnaby. If you're in the math department, you know she's Dr. Goebel now. But so this page is a little bit old, or the picture is a little bit old. Okay, so first we need to pull down the content of the website, and so here is that. I have it verbose again so we can see everything. That's the response. Here's what it looks like. Okay, there's lots of things that we don't really need to worry about too much, but we do see that it happened and it was okay. Okay, that's great. So now how do we work with that response? Okay, so we put that response into a function called content. Okay, first argument is response. Second argument is, well, raw. So what does the raw content look like? Well, the raw content looks like this, which is pretty useless. Okay, pretty useless. And so, well, we don't want that. We want something more. And so HTT returns info in raw bytes. Not very helpful. But we can use content text to get something more, a little bit more helpful. Now, this gives us back the whole website in the HTML form, okay? And so, but not really HTML form, it's just really long, one really long character. And so, we can use, well, stringer functions that you've learned about in a previous video to help us parse this. Okay, so maybe we're going to take that content text, okay, and now I'm going to use what you'll learn is a regex, or what you have learned is a regex, to scrape. And so I want to extract all emails from here. Flatten character is a per function to, well, flatten everything from a list into a vector, okay? And then pull out unique, and there we go. I have some emails. Okay? Now, here's the API examples that I can't use, but an API, which is an application programming interface, is an interface or communication protocol between different parts of a computer program intended to simplify the implementation and maintenance of software. Okay? Many places where you can gather data, especially from government entities, can be accessed through an API. So you query the API sends stuff to you. Okay? And so there are lots of different examples. Lots of different people use API. Okay, people love sports, and many of the major sporting bodies, or many of the leagues, pro leagues, the NFL, the MLB, the NHL, Major League Soccer, the MLS, so on and so forth. All of them collect massive amounts of data and give you some of their data. And so you can get those through API. If you're not a sports fan, you can get something, well, whatever you're interested in that has data, probably there's an API somewhere. I interact sometimes with the census. So the U.S. Census has an API, okay? And you can interact with the census API to gather census data. Okay, so, and there are lots of packages in R that are built to interact with the API. So you aren't writing the code necessarily that does that. You are using these packages, which have functions that are wrappers. Okay, so there's that. Now, we used to be able to look at something more fun that was Twitter. And so I have code here that I had run previously and worked. Okay, there's lots of different packages. There were multiple of them that worked with Twitter. They're sort of all obsolete now, unless you pay, and as I said before, maybe not even then. Okay, so you could run something like this, search tweets, and you could get back a number of tweets. And so that could be very helpful. That was very helpful for people who did a lot of text analysis of what people were talking about on Twitter. Okay, so anyway, that was one example of an API. Of course, it doesn't work anymore. So let's move on to rvest. Now, really, I talked about httr, but you aren't going to need to use httr on a daily basis. If you're going to do web scraping, you're probably using rvest. And so rvest is a tidyverse adjacent package for scraping HTML documents. So what do I mean by tidyverse adjacent? It is by the tidyverse people, but it isn't loaded when you load tidyverse. Okay, so you have to load it separately from tidyverse. Okay, so what rvest does is one will web scrape for you, so it will do the hypertext transfer stuff that httr did. Okay, but really the functions in rvest are made to use with HTML documents, or the language HTML. Okay, so HTML stands for Hypertext Markup Language. It's the standard markup language for creating web content. There are lots of different, there's HTML5 and there's lots of different stuff. We don't need to worry about that. But rvest has lots of functions for dealing with it. So rvest uses httr to obtain HTML from servers and then knows how to parse and search them properly. So we don't have to use our string r functions to find everything. Okay, now most web browsers have options to look at the HTML that generated the web page called the page source. And so that's what's, we're going to spend some time looking at page source stuff and then how that's going to help us pull stuff from that web page. So HTML marks up web pages with tags, which say what type of thing the object should be. So this is a very simple HTML document here. Okay, and everything inside of the less than, and then greater than, is a tag. Okay, so here in this very simple document, the first big tag is the HTML tag, and so you see it starts with HTML, and that tag is closed with the \HTML. So it starts it way at the top, it closes it at the bottom. Okay, there's a head, then a title, body, P, so on and so forth. They all mean something different, and we don't need to really worry about them. What type, we just have to know what the tag is, and then we're going to use rvest to search for the tags. Okay. So the rvest workflow that you're going to want to use first is read_HTML, and that grabs the web page in an XML format. Sorry, it's really raining outside, so you might have heard that lightning. But you read the HTML page in first. It grabs the web page in what's called an XML format. Okay. Then you're going to use HTML elements to filter out desired content. And then you're going to use HTML text or table to parse the content. So if it's a table, you want to parse it as a table. If it's text, you want to parse it as text. Okay. So we're going to do our same scraping. And so we're still going to use ship math faculty. So we're going to use the math faculty page. Okay. And so what does that look like? Well, it looks like this. An HTML document. This is the XML format that I talked about previously. So it's not really helpful. Okay. Although you will be able to tell quickly whether or not you actually scraped something or an error occurred if you look at the results. Okay, and so the question is, what type of node should I be looking for? What type of tag should I be looking for? Okay, and so to do this, let's actually look at this web page, which now the actual website I think has changed recently in the tag here. Now it's in Academics College's College of Arts and Sciences program, math faculty. It's a little bit different than what I had before, but what I had before will work. It just redirects you to here. Okay. So of course this is the page that is what we want to scrape. Okay. But we want to look at the source of what the page actually looks like. And so I'm in currently Safari, so I'm in the Mac one, and so I actually had to do some work to get here. You had to enable this develop tab, and then I would want show page source. Okay, and so when that happens, you get this, and maybe it'll make this. Okay, there we go. A little different. So this is what the website looks like, and there's a lot of stuff. There's a lot of stuff, but what we want to do, and maybe you just want to Control F and search. There's lots of things here, and we don't really know about a lot of them, but there's a lot of pages, and then we finally get down to here. And so this is where we start seeing our tags that we want. And so if you look here, we have Mr. Dennis Arnold, assistant professor, and then we have this. Okay, so right here we go. So we start and end a p tag. Okay, start and end a p tag. Inside the p tag, there's an a tag. Okay, a tag, and then it has a hypertext reference. So that's if you click on the email, it'll open up whatever mail browser that you have and try to send an email. Okay, so it has an href thing, and it also has a class email. So it's href this of class email. That's going to be helpful for us. And then here is the actual text of the a tag. Okay, and then it has a end p tag. And if you look, all of them are going to be the same. So if you find, where's his? Here, href class email. Okay? And so we can use that to look at the node. So we saw it was A, right? So the tag was A. And so I want to use HTML elements to grab all A tags, okay? Which is sort of helpful. But unfortunately, there were more A tags in there than just the email. And so I get a lot of tags. I get what they call an XML node set. Again, there were 82 A tags in the email. And so it pulls out 82 of them. I just want the emails. And so what I can do is I can dig down farther if that tag had something special, and it did. It was of class email. So what I can do is this. And so the dot is like the special. As usual, you'll see that dots are special. And so it's A with dot email. Okay, so A tag of class email. And that gets me a better node set of only 17, and it looks like it actually only has the A tags of class email. Okay, so that's what I want. And so I can take that and put that into, as I said, HTML text, and it pulls out the innards of the A tag with class email, which were the actual emails. Okay, and so there I got that. So you could also scrape tables, pictures, anything you want, of course, if you're allowed to. Now, something that I should mention is that you're not always allowed to scrape websites. Okay, so Shippensburg clearly allowed me to scrape that website. But if the website contains important information, if that person has put on a special anything that they don't want it to be scraped, they're allowed to do that. You can look up laws, so on and so forth. But sometimes you're not allowed to scrape a website. That doesn't mean, even if you're not allowed to, you still can. There are ways to illegally scrape things. I've heard stories. I talked to some people who were scraping websites as sort of like not nefarious, but in a more professional way, and they got cease and desist orders from those places. So it is important, and people actually care about it. One place that you can see many websites, not all of them, but many websites have a special text file at the end that tell crawlers what they are and aren't allowed to do. So if you go to a website, you'll see in a second, there's a website for stock images here called Pixabay that you can look at stock images, and if you add on robots.txt, you get this. So this is just a text file, and so you can see what it allows and it disallows. So it allows API documents, but it disallows all of this. Okay, and so image downloads would be something like what we were trying to do if we were trying to scrape this website to get a picture. Okay, and so many websites have these. Okay, sometimes it's in the HTML of the original page. They put special permissions that you're not allowed to do it. But anyway, so you should know, you should check before you scrape a website if you can or can't do it. So another story that is funny is that my wife also is a data scientist, and she was doing a project just for fun that was looking at Taylor Swift lyrics. And she was trying to scrape some Taylor Swift lyrics from a website, and she did it too fast. So if you sometimes they have rate limits on what you can do, and if you can do it, she did it too fast, and so now she is permanently banned. Her address is permanently banned from xyzlyrics.com or whatever lyrics place we are, or at least a sort of temporary ban. Okay, so you can get yourself in trouble, probably not legal trouble, but you may not be able to visit a website for a while or anymore. So anyway, there's that. Now, there is an example. So the example here is a package called PUPR or Pupper. My wife and I created this package. And so if you look up PUPR package, okay, you're going to find it. Now, there are two of them. This guy is pup production of harp and hooded seals. That's definitely not it. Okay, this is the better package here. Okay, I don't have this downloaded on my machine yet because I just got a new one, but we'll try to do some live coding, although this may just go wrong here. But we're gonna install some stuff. Okay, so anyway, we've got some interesting, we got a warning here, something had exit status. So either I haven't checked on this package in a while, or my, let's see. Imager. Something weird with the Imager package here. Okay. Well, anyway, I don't have... I'm sorry. Anyway, it's something weird with my computer. But you can try this, and you can do this, and if it works, what it does is when you run a function, it will load a picture of a dog in your plots window, or rather your viewer window. And so if you are running code and it's really frustrating and you're not having a good time, you can use the pupper package to load an image of a dog, a cute dog in your space here, so you can keep going. You know, some people need that. It's a very popular package, in fact. But anyway, not working for me because I don't have it set up right. But maybe I'll get it set up right and show you in another video, or you can try yourself. Okay. So anyway, that's the end of the web scraping slides. There is a data cleaning example here, but we aren't going to do that yet. This would be more of an in-class thing, and so we'll skip this for now. So hopefully that was helpful and you know a little bit more about web scraping.